Hello friends, today we are going to learn what is trie. Let's learn it through example. App and apple. So initially there is a root node which is empty string. Now first check if the root node has a as children. No. Then append a to the root node. Now after this, now node is children node, that is a. Now append p to it. Similarly p. Next p. So now the interesting part comes up, which is since A is in the node, move to next node. Move to next node until you find the node which is different. Now L, now E. Now run this example in your mind until you get the concept. Okay, now let's see how to implement it. So let's see how to represent trie data structure. In the trie data structure, we have first solution as an array to represent in C++ and Java. Okay, we have to initialize as children and n, which is the number of characters we can store in the tree node, okay, as a second node. Okay, now second solution is map. We can use the hash map if we are using it in Java. Okay, you can read this stuff. Now let's move to implementation part. Okay, in the implementation part, a trie or a prefix tree has various functions and a class node. So let's begin with this. It has insert function which inserts the word into the trie data structure, and a search function which returns true if the string word is present in the trie, otherwise false. And same goes with this starts with. So now let's implement in the JS thing. Okay, so we make another class also. Okay, which is called node. Okay, now in this we'll make two variables. This dot children, that is a dictionary or a JSON object, and this dot is word, which is false initially. Now in this trie function we will make a root node. This dot root, that is equals to new of node. Okay, it is an empty node. Okay, now after this we will start making the insert function. So in insert function we will make a variable let node equals to the this dot root node. Okay, now run a for loop. I don't know more of the JavaScript for loop, so let's begin with a simple one. For let I equal to 0, I less than word dot length I plus plus. Okay, in this we are going to first make a variable c. Let c equals to word dot char at I. Okay, now after this check if the word is in the thing or not, in the node or not. Okay, so c in node dot children, and we will take note of it. So let's do this. I'm doing this because not is not a operator in this. Okay, node dot children of c equals to new node. Okay, otherwise node equals to node dot children of c. Okay, and in the end node dot is word equals to true. Okay, now we will do the same to this function for searching till this part, because we are searching if it is present, then do this, otherwise do this. And in the end, what we are going to do is, if nor dot is word, let's wrap in a bracket so not to get any error, then return true. Okay, and otherwise return false. And there will be case if the C is not present. Okay, the word, the character of this word is not present in the try, then simply return false. So to fastly give up on this thing. Okay, now simply take this one. Actually, I am so lazy one, so that's why let's put a semicolon here. I love semicolons. uh, and then in this part simply return true. So let's unwrap this, because if we found the prefix, then you have to return true. Okay, also do one thing, remove this return false and the unnecessary bracket. And in this part, what we are going to do is, let's take this one word and do it and replace it with prefix. Same goes with this one. Okay, so if we run it, okay, so we have the same result. Now let's submit it. Okay, it is accepted. Now let's see where can we use this implementation in any application, like they said. I'm very curious to know about it. How can we use autocomplete or a spell checker maybe? So let's do that part.